Easy. So this was a really easy one to start us out with. So we're going to be dealing with sequences. So 2, blank, 6, 8, 10. Your logical thinking skills told you that question mark was 4, right, everyone? Okay, so how did you see that? Can you explain to your group how you were able to know it was definitely probably 4? Go. Okay, I'm hearing exactly what I'm looking for and exactly what a sequence you're going to see. So, why did you know it was 4? There's a pattern. That is true. There's always going to be the same pattern between each set of numbers. Okay, and there's a difference of, I heard this group, number 1, say, there's a difference of 2 between each. Is that how you guys are seeing it? Okay, perfect. So you guys were just dealing with an arithmetic sequence. You're going to want to take some notes. Notice you have 2 papers, the worksheet and then a formulas worksheet. Do not lose the formulas worksheet. We're only going to be using the top formula, so put a star by that today. The very top formula there, where it says sequence, arithmetic sequence, and next time we'll be doing arithmetic series. Okay, so you're going to want to maybe take some notes today as well. So my examples will be coming off your worksheet, but you're going to need to do some work on a separate sheet of paper. Okay, so an arithmetic sequence of numbers has a common difference from one term to the next, just like we saw in the Bell quiz. So if a sequence is truly an arithmetic sequence, it will definitely have the same difference between each term. If it doesn't have a common difference between each term, it is not considered arithmetic. So meaning we can add the same number each time to get from one term to the next. It's got to be the exact same or else it's not arithmetic. So not all sequences are arithmetic, and you're going to be asked, is this arithmetic or is this not? So let's first look at this example here. It says, determine whether, is that how you spell the right weather? That's like the weather as in like, what's the weather? Okay, so teach me how to spell it. Like I didn't have to write a paper my entire degree, so just math stuff. Okay, W, E. You guys don't know how to spell it either. That feels weird. Okay. All right. Sounds like we all struggle with English a little bit, including myself. In fact, I've had multiple boys that I've dated say to me, you have the worst grammar. I'm like, I'm a math teacher. Give me a break. All right, here we go. So number 1, it says determine whether each sequence is arithmetic. If so, identify the common difference. So here's the thing, guys. Let's look at number 1 here. Is this one arithmetic? So here's what we're going to do. We're going to take the difference, and you always want to start with this minus this. So the term that comes before the term behind it. So 8 minus 5 is 3. We're going to look at common differences. So then 3 minus 5 is 2. 2 minus 3 is 1. So we added 1, then we added 2, then we added 3. This is a pattern, but it is not the same every time. So it's not arithmetic. Does that make sense, everybody? This is still considered a sequence of numbers, but it's not an arithmetic. So we would say no. Why not? Because there's not a common difference. Difference means subtraction. So not a common difference. And you don't need to write that. I'm just writing that to make sure we're good. All good with that one? Pretty easy to determine if it's arithmetic or not. Okay, let's do number 2 on your worksheet. So you're doing it so you don't have as much homework. Determine, I'm going to spell weather wrong every time, just saying. Wait, let's look at our paper because that should be right. That came out of the book. Okay, cool. Determine whether each sequence is arithmetic. If so, identify the common difference. Once again, make sure you do this minus this. The term that comes before the term before it, because we're going to be adding to get from one term to the next. So negative 9 minus negative 6. Negative 9 minus negative 6. Negative 9 plus 6. Negative 3, which makes sense, guys, because I'm going to be subtracting 3 to get from this term to this term. Okay, let's do this one. Negative 6 minus negative 3. Negative 3, good. And let's check, let's make absolute sure. Negative 3 minus 0 is negative 3. Was the difference the same from one term to the next on each term? Yes, so it is arithmetic. We subtracted 3 each time to get to the next term. So yes, and then it says, if so, what's the common difference? So just do CD, common difference is negative 3. Okay. So what you're going to do is 1 through 10. You're going to tell me, is it arithmetic? If not, then say no. If yes, tell me the common difference. Ready, set, go. Because this is new, the hardest part for people is the terminology. If you pay attention to this, it's really going to make it less confusing. So everybody pay attention to this because really the terminology is what gets people. They're like, wait, what does that mean? So we're going to talk about some notation, what you're going to see. So here's an example of an arithmetic sequence. So this would be considered my first term in the sequence, second term, third term, fourth term. Does everybody understand? So this is how they write the notation. A sub 1, this is like a little mini 1, that's how they state the first term. So this would be considered A sub 1. So A sub 1 just means the first term in the sequence. For this sequence, it's 2. Does everybody understand? A sub 2 means the second sequence, so that would be 4, A sub 3, A sub 4, and so on. So A sub 3 means the third term in the sequence, and this it's 6. So now, if we're talking A sub n, that means the nth term, or really what it means is you're going to hear me say it as the any term. We can talk the 10th term, the 43rd term, the 100th term for that sequence. So A sub n means any term in the sequence. Does everybody understand? So if I said A sub, oh, I wrote it down. Oh, no, let's see. So if I said A sub 20, what term would I be talking about? The 20th term, right, everybody? Okay. So now you're going to see this notation as well. Make sure you understand what it means, because it always throws people off, but you have to remember what it means. So let me scroll up for you in the back. So A sub n means the nth term, any term in the sequence. A sub n minus 1 means the term that comes before the term above it, so or the previous term. So think about it, guys. If this is A sub n, wouldn't A sub n minus 1 be before A sub n? Does that make sense? Look, minus 1, that means we're talking the term before. So anytime you see the thing A sub n minus 1, you're not going to calculate anything. That just means the term before, the previous term. So then A sub n plus 1 means the term after A sub n, or the next term. So that would be like this, A sub n plus 1. So an example of that would be, for example, if I said let, I'm choosing, because A sub n can be any term, let A sub n be 6, and in that example up there, remember it was 2, 4, 6, 8, right? So what would this term be? 8, and this would be 4. Do you guys understand? So the previous term would have been 4. Does everybody understand? If I called A sub n 6. No one's confused? All notation. Okay, awesome. That's always what gets people. So tell me, what's A, I'm just testing you, what's A sub 1 in this? 0. What's A sub 2? What's A sub 3? 6. Very good. Just curious, what's the common difference in this one? 3. Very good. And then I'm choosing, let A sub n be 3, so what's A sub n minus 1? 0. You guys got it. What's A sub n plus 1? 6. Very good. Okay, so now we're going to go back to the worksheet, and I'm going to help you understand a few things. So it says, find the 43rd term of the sequence. So let's look at number 11. 12, 14, 16, 18. So this is A sub 1, A sub 2, A sub 3, A sub 4. It's asking us to find the 43rd term. Isn't that going to take us all day long to list out all of those till we get to 43rd term? That's going to take us all day. Luckily, that's not how we're going to do it. So we are not going to do it that way. This would take us way too long by finding each term until we reach the 43rd term. So instead, what we're going to do is we're going to write ourselves a formula to help us find any term in a sequence. So there are two types of formulas, and you're going to want to write this. This is not written anywhere. Maybe flip your paper, even like your little formulas worksheet, flip to the back and take notes on this. So what we're going to do is we're going to take and we're going to write a formula for this particular sequence to help us find any term in a sequence. So we're going to have A sub n equals some formula that will generate any term in this sequence. There are two types of formulas, an explicit formula, this is where you're taking notes, an explicit formula and a recursive formula. Now, explicit formulas are the ones that we use most because you don't need to know anything at all except for the common difference and the first term. So if we know the first term's 12 and we know the common difference is in this one 2, correct? common difference is 2. We can then create an equation, an explicit formula, to generate any term in the sequence, no matter what. And it's this formula. So notice this is given. So a sub n means any term in the sequence will be equal to a sub 1, the first term in the sequence, plus n minus 1, where n is just a variable. N is the nth term you're plugging in. So the nth term you're trying to find. So n minus 1 times by d, where d is the common difference. So a sub 1 is the first term, d is the common difference, and n is the nth term you're trying to find. This is the most usable formula because you don't have to know anything but the first term and the common difference, and you'll always be given that. So a recursive formula is a lot easier to do. It's a lot easier to write. However, it's not very useful because you must know the previous term to actually use the recursive formula. So the recursive formula is this. A sub n, any term in the sequence, is the a sub n minus 1 plus d. Now remember what that really means. That means you take the previous term, a sub n minus 1 is previous term, and then you add the common difference. So this one's like the more straightforward formula, but it's not really helpful, to be honest. But you're still going to be asked to write one. Remember that n minus 1 just means the previous term, and then d is the common difference. So we're going to write an explicit formula and a recursive formula for this, and then we're going to choose which one we would want to use to find the 43rd term. If we have a formula, it allows us to find any term in the sequence, which we're going to want to use because otherwise it takes way too long. Okay, do you have that written down? Do I need to give you more time? So now I have that same thing written up here. Let's look at number 11. So it says, find the 43rd term. So what I'm going to do is say, I need to generate a formula. There's two types of formulas, explicit and recursive. So let's write an explicit formula for this. So first of all, we know our a sub 1 is 12, and our common difference is 2. That's the first thing you're going to identify. So now let's write the explicit formula using this formula. So for this sequence. So we're going to say a sub n, which means any term in the sequence will be equal to a sub 1, what's my a sub 1? 12 plus, now in a minute we will plug in 43, but right now we're just using the variable n. So n minus 1 times by the common difference. See, times by the common difference, which is 2. Now we have a formula that will allow us to find any term in this sequence. What I want us to do is simplify that, however. So let's simplify that. 1 I multiplied 2 into both of those. Let's get a simplified formula. Okay, let's multiply 2 in, everyone. Here we go. A sub n is equal to 12 plus 2n minus 2. Correct? Now combine like terms. So our explicit formula is a sub n is equal to 2n plus 10. Does everybody see? Okay. So now I'm going to put a box around that. That's an explicit formula. Now watch how that works. I'm going to come right here and just take an all erase. So watch how that works. If we want to make sure this is the right formula, we could check by plugging in, where's a sub 1? So watch, if I plug in 1 here, that's 2 times 1, right? Does everybody see what I'm doing? A sub 1, I'm going to check to make sure the formula is working here. If I plug in 1 here, that would be 2 times 1 plus 10, which is 12. Let's see if a sub 2 comes out right, which that one came out right. Let's plug in 2. A sub 2, so plug in 2. 2 times 2 is 4. 4 plus 10 is 14. Do you see how it's generating the correct things here? This formula. Okay, awesome. So I was just showing you that it really does work. Okay, so we're going to remember that formula. Now let's write a recursive formula. This one's the easy one. What are we doing? Are we taking the previous term and adding 2 to get to the next term? That's what a recursive formula is. You use the previous terms to write a formula. So you'd say a sub n is equal to the previous term, which is written as a sub n minus 1. You take the previous term and you add 2 to it. That would generate these sequences. These sequence of numbers. You take the previous term and add 2. Previous term, add 2. So this formula isn't very helpful because think about it. If I said to you find the 43rd term, wouldn't you need the 42nd term? And then why even use the formula? Because then just add 2 one more time and you're there. So we don't really use this very often. Okay, so let's use the explicit formula. This is always the one we'll use because it's very straightforward, and you can find any term in the sequence using that. So now we know that this is our formula, and it's asking us to find the 43rd term. So we want a sub 43. So all we have to do is now plug it into our formula. So that'll be 2 times 43 plus 10, because we're asked to find the 43rd term. So tell me what we get here. 96. So a sub 43 equals 96. So the 43rd term, we went like this and went all the way to 43, would have been 96. Okay, questions on that? So if you can write an explicit formula, then you can find any term in the sequence. Okay, let's do number 12. Let's practice another one. So here we go. It says, find the 43rd term. So let's do the explicit formula here. Now, a sub n means any term in the sequence will be a sub 1, which is 13.1, right? 13.1 plus n minus 1 times the common difference. Let's hurry and find that first. So you'll do negative 16.9 minus negative 6.9. Somebody really quick? Negative 10. And then we could check another one, but that is negative 10. Does everybody see how the common difference is negative 10 in this one? So our common difference is negative 10. Here we go. Let's plug it in. Oh, times by negative 10. There's the formula that we just used. And now let's just simplify the formula. Times negative 10 in. So we have a sub n will be equal to 13.1 plus negative 10n plus 10, correct? So combine like terms, a sub n, any term in this sequence can be found by taking, let's add up like terms here. So isn't that 23.1? Perfect. So we have negative 10n plus 23.1. That is how we can find any term in this sequence using this formula. So now we want to find a sub 43. So let's plug that in. The 43rd term. Okay, awesome. So we're looking at this. So a sub 43 is your negative, I think on mine I got negative 406.9. Is that what you said? Yeah. Perfect. Negative 406.9. So the 43rd term is negative 406.9. Once again, you would not have wanted to sit and subtract 10 a million times. Well, to be exact, 43 times till you got there, because that would take you all day long. Okay, any questions on this? So let's do, for kicks and giggles, let's write out a recursive definition, a recursive formula. So it would be a sub n, any term in the sequence will be the previous term, a sub n minus 1, and then aren't we taking the previous term and subtracting 10 from it? Isn't that what we did to get from here to here? The previous here to here? So you would say the previous term minus 10, and that would not be used for this one. We're going to use the explicit formula. But that's good practice because on the test it does say write an explicit formula, write a recursive formula. Okay, awesome. Okay, do we need another one or are you guys good? You're good? Okay, awesome. So do 11 through 20, ready, set, go. So in this next one, it says find the missing term. So we're going to be in this next section here. Find the missing term of each arithmetic. It tells you it's arithmetic, so we know it's going to have a common difference between each term. Find the missing term. There's two ways of doing this. So there's two ways of thinking about it. So first of all, way number one. This way is my favorite way because it's just setting up a true statement and then you can just solve straight up for what you're missing. So do you see? So everybody watch because you might prefer one way over the other. And it really just depends on the problem. One way might be more useful than the other. So let's look at this one. We don't know what this is. Let's call it X. Everybody good with that? So let's set up a true statement. Isn't it true that if we take this, so there'll be a common difference between each term, correct? So won't this minus this be the same as this minus this? Does everybody understand why? So that's a true statement. This minus this, 49 minus X will be equal to, what's the next true statement? X minus 23. Now let's solve for x, because that's what we're trying to find. We've set up a truth statement, and now we can just solve for x. Everybody understand? Okay, let's do that. So let's combine our x's, so we would add x to both sides. So that's 49 equals 2x minus 23, correct? Anybody confused? Right? Did I, oh, it's, let's see. Yep, perfect. So then we'll add 23 to both sides of the equation. So we get, yep, 60, 72. So we would add those up and we get 72 is equal to 2x. Now we're trying to solve for x. So we would divide both sides by 2 and x equals 36. Voila, we found x. That's one way of doing it. Now, a lot of you have already, I've noticed, moved on, which is great. A lot of you got it right doing it a different way. So somebody tell me the other way you thought through how to do it. Okay, so you added them up, basically, and then you divided it by 2. Okay, that is another, and then that gave you 36. And then even another way of doing it is to do 49 minus 20. So this is how I was going to do. Okay, that's great. You can add them up and then divide by 2. So isn't that finding, that's called finding the arithmetic mean, meaning like the average of both. Does that make sense, everybody? So you did 23 plus 49 divided by 2. Perfect. That's exactly what I was looking for. So 36. Any questions? There's even one more way that I thought through it. I did, because this way might help. Some with ones that get a little bit harder. So everybody, let's think about it this way too. So really, let's do way number 3. Okay, so isn't it true that between, we're going from 23 up to 49. How much is between that? You do 49 minus 23. We get 26, correct, everybody? But it's got to be split evenly. So we added 26, but then we didn't add 26 to get to 49. Like, sorry, let me say this one more time. Divided by 2. Sorry, I'm not explaining it very well because I'm like seeing it without not being able to explain it very good right now. So let me try one more time. To get from 23 up to 49, there's a difference between here to here of 26. Correct, everybody? But how many times, we had to add something twice. So don't we need to divide it by 2? So divide it by 2. So we actually added 13 each time. So if we add 13, we get to 23 plus 13 is 36. Add 13 is 49. Does that make sense, everybody? If you think of it that way, sometimes it's helpful because you're going to see times when they do this. Let's say that I put a box here and then put 62. So that's going to be how you would think through this one. A little bit more of an advanced one is the way I just did it. Does that make sense? In a minute, I'm going to test you to see if you can do one like that. Okay, awesome. Because there is one like that on the test. Okay, what I want you to do is practice 21 through 32, whichever way you want to do it. This is the level that you're going to see on the test. So if I said to you, find the boxes, this is an arithmetic, I'm telling you it's arithmetic, find the boxes, we'd have to think a little bit more about this one. So first of all, this is how I would do this one. So first of all, we know this is a sub 1, correct? A sub 2, a sub 3, a sub 4, a sub 5, right, everybody? So to get from a sub 1 to a sub 4, how much did we add in between? So everybody, in your calculator, do 35 minus 14, 21. So we've added 21 stretched across here. But we've got to add the same amount each time. So how many times did we add some amount? So we added some amount one time, correct? We added some amount another time, and we added some amount, and that would put me here, correct? So how many times did we add that amount? 3 times. So it's got to be split evenly. 21's got to be split evenly amongst 3. So 21 divided by 3 equals 7. So what we did is we added 7 each time. So 14 plus 7, right? And then add 7 again. Is everybody understanding? And then 28, 35, and then add 7. 43, right? It is 42. I can't add very good right now. This was just an advanced example, making sure we could do that for the test. Okay, so it's just being able to use your logical thinking. Okay, awesome. Okay, let's go to 35 real quick. It's asking us the same thing, but this is all in notes, so don't let notation mess you up. So it says, find the arithmetic mean, a sub n, of the given term. So it's all in deciphering. Can you now put what you're looking for together? So it says find the arithmetic mean, a sub n. So it's telling us to find a sub n. So don't we know a sub n minus 1 will be here, and a sub n plus 1 will be here. So that means that this will be 5, comma, this is what we're trying to find, comma, 11. You see how this is no different than the ones we just did? So it's just really deciphering what am I talking about. You can't let notation throw you off, and you've got to think, what is this giving me? And draw yourself a picture if you need. So then you can do this however many ways you want. The arithmetic mean, you do 5 plus 11, which is 16, divided by 2, which is 8. So my answer would be 8 for that one. All right, so what I'm going to have you do is do 35 through 40 now. Let's all go to 46 real quick. So it says, now this is where it really does come in the real world. I know people run into this all the time. So it says, each year a volunteer organization expects to add 5 more people. So go to 46 on your worksheet. Each year a volunteer organization expects to add 5 more people to the number of shut-ins, whatever that means, for whom the group provides home maintenance service. Oh, people that don't need the house. Okay, cool. So this year, the organization provides the service for 32 people. So are we starting out, guys, this is what you have to decipher. Aren't we starting out with 32 people? Yes? Right? Okay. So it says this year the organization is 32 people. So let's write that out. A sub 1, the first term, is 32. Now it says, write a recursive formula. So now it says each year, the volunteer organization expects to add 5 more. So our common difference will be 5, won't it? Okay, write a recursive formula. So that means using the previous term. So you would say a sub n, any term in the sequence, will be the previous term, which we write that as a sub n minus 1, you take the previous term, and then you add 5. This is the one that's just very straightforward. However, not the most usable, depending on what we're talking about. So number B, it says write the first 5 terms of the sequence. So this one's great. This one's easy. 32 plus 5 is plus 5, plus 5, 1, 2, 3, 4, and plus 5. Okay, so the first year they have this many, second year this many, third year, fourth year, fifth year. Everybody understand? Okay, awesome. It says write an explicit formula. So let's write it out. We would say the explicit formula is a sub n is equal to, remember it's a sub 1 plus n minus 1 times by d. So a sub n is equal to, a sub 1 is 32 plus n minus 1 times by the common difference of 5. I do want you to simplify it, so then you'll multiply 5 in. So we're going to have 32 plus 5n minus 5, right? So a sub n, I can't really fit it very good. 27, and let's put it in, let's just go, a sub n is equal to 5n plus 27. So that's the explicit formula for this. That will generate any term in the sequence. So now it says, how many people would the organization expect to serve on the 20th year? So isn't that a sub 20? Okay. It is a good one. So let's plug in 20 here for n. So we have 5 times 20 plus 27. What is it? 127. Very applicable in the real world. Okay, so it's just deciphering what you're talking about. Okay, the rest of the time is yours to finish the entire worksheet. Nothing any harder than that or any easier than that, just about the same as that. Ready, set, go.